Hello. This is a video on synthetic division. Synthetic division is a way to factor high-degree polynomials, and therefore it's a way to find zeros of a polynomial. And it's therefore going to give us the x-intercepts of the graph of the polynomial. This was our trifecta. Factors give zeros, which give x-intercepts. Let's look at our first example. We want to find the zeros of the function f of x equals 2x to the fourth minus 7x cubed plus x squared plus 7x minus 3. In other words, solve the equation where the polynomial is equal to 0. Let's take a look and see what Descartes' rule of signs tells us. We first of all look at the sign changes in the original f of x. Here's a sign change from positive to negative. Here's a sign change back to positive. And here's a sign change back to negative. There are 3 sign changes. Therefore, there are 3 or 1 positive real solutions. Now, if we look at f of the opposite of x, this is going to stay a positive because it's an even exponent. This is going to change to positive 7x to the third. This is going to stay the same. This will become a negative when we plug in a negative x, and this stays the same. So if we look at the sign changes here, there's only one sign change from a positive to a negative. So therefore, there is going to be one real solution that's negative. Now let's look at the possible rational roots from the rational root theorem. They're going to be of the form p over q, where p is a divisor of 3, so the numerator is 1 or 3, or negative 1 or negative 3, and the denominator is 2. So here are the possible rational roots. So there's 8 possibilities. We're looking for 4. So now let's take a look at synthetic division. Okay, synthetic division is a shorthand system that's actually quite easy to execute. So you take your coefficients 2, -7, 1, 7, and -3, and you write them across here with a little bit of space in between. The number that you're going to be substituting in, the root that you're checking is going to go in this box. I'm going to go ahead and check positive 1. So I put positive 1 in this box. The first step is easy. You simply bring down the 2. Then we multiply by the number in the box. Well, that's going to be very easy in this case. 2 times 1 is 2. Then we add coming down and we get a -5. Multiply -5 times 1, we get -5. Adding coming down, we get -4. -4 times 1 is -4. Adding coming down, we get +3. 3 times 1 is 3. And then adding coming down, we get 0. And when we get 0, we're really happy because this is the remainder. It actually means 2 things. It's the remainder when you divide by x minus 1, and it is also the value of f of 1. Sometimes this is called synthetic substitution. Let me draw in another line here. I draw in a line to the left of this. This separates my quotient from my remainder. These now are the coefficients of my next polynomial. I have started to factor the polynomial. Let me write out the factoring. So I've got it started. When I have 1 in the box, and it did work, it means x minus 1 is a factor. Then I'm going to use my coefficients here. I'm going to have 2 times x to the third power. So I take these coefficients from here, 2, -5, -4, 3, and I put them here. Notice x to the first times x to the third will give me x to the fourth. Now I proceed. Now I'm going to proceed and I'm going to try to factor this polynomial right here. I could try 1 again. I don't think I'm going to try 1 again. I'm going to go ahead and try 2. So let's see what happens with 2. First thing you do is bring down. Then you multiply by the number in the box, which is 4. Then you add coming down, which is -1. Multiply by the number in the box. -1 times 2 is -2. Add coming down, which is -6. Multiply by the number in the box, which is -12. And add coming down, and we get -9. So in this case, I did not get a remainder of 0, which means 2 is not a solution. X minus 2 is not a factor. So I did this in pencil, so now I'm going to erase. Actually, I should not have tried 2. That was not a good idea because 2 was not a possibility. But 3 is. So let's try 3. Bring down 2, multiply by 3, which is 6. Add, which is 1, multiply by 3. Add, which is -1. Multiply by 3, which is -3, gives me a remainder of 0. Bada bing, bada boom. X minus 3 is a factor. So now, over here on the right-hand side, I can continue with my factoring. I still have the x minus 1 factor, but this cubic polynomial has now factored into x minus 3 because of this 3, and then using these coefficients of 2, 1, and -1, I have 2x squared plus x minus 1. Once you get to a quadratic, you can do the rest of it by hand. So let me do that. So I know that my first terms are 2x and x. I know my signs are different in order to get a negative. So it's going to be a negative times a positive. I don't know if the negative is going to go with the 2 or with the 2x or with the x. So I do a little bit of trial and error. And I believe this is going to work. First times first is 2x squared. Outer is 2x and inner is -1x, which gives me x, and last times last is -1. And so now I have factored this completely and I can write my solutions. So there are the 4 solutions, 1, 3, 1/2, and -1. This does check out with what Descartes' rule of signs told us, and it checks out with the rational root theorem. Now let's graph this so we can see the 4 solutions. Now I'm using Desmos. Desmos and GeoGebra are both very nice programs. Desmos is a little easier to use, but not as full-featured. I have written out the polynomial here. 2x to the 4th minus 7x to the 3rd plus x squared plus 7x minus 3. And let's take a look at our intercepts here. Sure enough, -1, 0.5, +1, and 3. Let's do one more example. I'll do this one a little quicker. You can pause the video as needed. We're trying to find the zeros of the function f of x equals 3x cubed plus x squared minus 48x minus 16. Descartes' rule of signs, there's only one sign change right here, so there's one positive real solution. That's really good information. And if we look at f of -x, we have a sign change here and a sign change here, which means there's going to be 2 or 0 negative real solutions. So now the rational root theorem, the numerator needs to be a divisor of 16. The denominator needs to be a divisor of 3, which would be 1 or 3. So we have a lot of possible rational zeros, plus or minus 1, 2, 4, 8, and 16. And then all of those 1, 2, 4, 8, and 16 over 3. So here's our polynomial. We put down the coefficients without any x's, just cold, naked numbers. And I'm going to try 1/3 here, so you can see how it works with a fraction. So we bring down the 3. 3 times 1/3 is 1. That's going to give me 2 here when I add, and 2 times 1/3 is 2/3, so I'm getting into some fractions and I can see that it's not going to work. So I'm going to erase this, and I'm going to try negative 1/3. So I bring down the 3. 3 times negative 1/3 is negative 1. Add coming down, that's 0. 0 times negative 1/3 is 0. Add coming down, you get negative 48. Negative 48 times negative 1/3 is a positive 16. I love it. And I get 0. So I have found a solution and I have found factors. So let me factor over here. So when I have a negative 1/3 is what was substituted in, it means the factor is x plus 1/3. And I use these coefficients 3, 0, and negative 48. I get 3x squared plus 0x, which I didn't write in, minus 48. Then I can proceed by hand, and let's see what we get next. In this binomial, I can factor out a 3. And I'm not quite sure why I copied that, but here we are. It's factoring out a 3. 3 times x squared and 3 times negative 16 is negative 48. Now, if I factor x squared minus 16, I get x minus 4 times x plus 4. And then when I set these factors equal to 0, I get 1/3, negative 1/3, excuse me. Getting kind of sleepy here in the middle of the night. 3 equals 0 does not give any solutions, and my other solutions are 4 and negative 4. The fundamental theorem of algebra said that I should have gotten 3 solutions, and I in fact did get 3 solutions. My name is Jim Olson. Good luck using the synthetic division method of factoring. Have a great day.